Yeah, I'm talking about Apache Cassandra, and I have, I think, three minutes to talk about DataStax Enterprise. So just keep a focus on Apache Cassandra because this is open source, and I think you're interested in that. This is the agenda. So a short introduction, as always. Then I would talk a bit about Apache Cassandra and where it comes from, what it does, and how can it help you to have an enterprise-ready database under your software. And then I will have a data modeling example for the Internet of Things, so sensor data, time series data, and stuff like that. And then we have the 3 minutes for DataStax Enterprise. I skipped, I think, 15 slides to have no sales part. And then I will give you a short view in what's coming next with Cassandra 2.1. So my name is Christian Johansen. I'm a solutions engineer at DataStax, so I'm not the typical committer of code. So I think we commit nearly 80% to the code of Apache Cassandra. And you can find me everywhere on the internet, so I don't hide anything, so you will find crappy photos and all that stuff with me. So just take a look. So short introduction. I always refer to that because maybe it becomes important when we talk about availability and stuff. So there's a CAP theorem. So Eric Brewer, I think, is the one who stated this out. So he tells us that in distributed systems, consistency, availability, and partition tolerance in a mutually dependent dependent relationship. So enhancing any two of those will diminish the third. And Apache Cassandra is for availability and partition tolerance. So everybody asked me and said, oh, okay, yeah, you are NoSQL, so this is eventually consistent. And I said, yeah, it could be if you want to. So let's see in a later slide what this means to Apache Cassandra. This rule is fit in this case as well, but I can show you how to change some of these facts. So Apache Cassandra, I think everybody knows what Cassandra is. So it's the massively scalable and available non-SQL database. I think NoSQL is a bit strange as a term. And Cassandra is or was designed to handle big data workloads across multiple data centers. So we will see that in a few slides, how data centers are handled with Cassandra. And there's no single point of failure. And I think that's some of the most important facts that Cassandra is aware of, that everything could fail. So we have some crash monkey scripts and stuff in some demos just to show that we are not knowing how a data center can be corrupted. And it's provide enterprise performance. So it's really fast. Cassandra is written for writes. So you will see that later on. I have a study screenshot, and you can also download the white paper from the University of Toronto, I think was it, and there you can see the scalability and the performance. So it's based on Dynamo and Bigtable. I think that's the short part of the story. If you want to see what exactly the definition of Bigtable and Dynamo is, you can just visit those links. I think it's possible to post the presentation afterwards in the meetup group or something. So, as I told you, Apache Cassandra is one of the biggest facts, and I think that's a difference to Mongo with replication, for example. It's masterless. So all the nodes have the same role. So in fact, there are no roles. These are Cassandra nodes. So you can write and read anywhere in the ring. So with this, it's a continuous availability, so you don't have any outages. Yeah, it has multi-data center and so on support. Yeah. And these nodes talking to each other with some called gossip protocol. This is what refers to the opposite of master-slave. And it has a flexible data model, so you can use unstructured data, as I've done with tweets, for example, just to decode them or deserialize them in JSON and push them into the database. Yeah, it's fast, and yes, it works because it's just a write, but sometimes it's better to think about your queries. So what is the goal you want to reach? What is the data you want to have out of your database? Because read is one case, read is the other. So you can store semi-structured and structured data as well. And we will see what this means to data if we look into the shell and the data model. Maybe if there's some time left, I have some live environment on my notebook, and we can just check how this is working in a cluster. So the linear scalable performance is stated out as scale out and scale up. So you're always able to add nodes to the ring without any outages, without any downtime, and you can also scale up or replace nodes in the production environment without any outages. Okay, that does not work with a 2-node cluster, but if you have 3 or 4, it should be working. So this is directly linear scalable. So with the Cassandra comes security, so you can add users to your table and you can give them access or you can deny access, and it's operationally simple. So we will see in a few minutes how my Vagrant script looks, for example, or how to deploy a cluster. That's really easy. It's just a few config files. Everybody, I think, is aware of Chef, Ansible, and all that stuff, so it's really easy to bring this up. And it has in the Neo versions the so-called CQL, Cassandra Query Language. Before that, in the versions before, there was a protocol called Thrift. And yeah, to be honest, I used Mongo a lot before, and I was surprised how hard it is to connect to a Cassandra cluster with the Thrift protocol, because it was in Python even 5 lines of code just to connect. And I thought, okay, that could be worse. Yeah. So this has changed with CQL. And as you can see, this image just shows an example of the linear scalability. So in case you have 100,000 transactions and you will have 200,000 just at 2 nodes, so it scales linear, nearly. So sometimes there's a bit a peak, but that's not like peaks anymore. So how's the Cassandra adoption? Actually, yeah, I choose the one from February because I think there was the highest stand actually. So don't get me wrong, this is from February, dbengines.com. You can see this. I think we are now on 10. No, then it's the same. So I think in the meantime there was something like 8 or 9. So it just shows how the adoption of those databases is actually. Some important terms. I had a meetup yesterday, and afterwards all the people asking, hey, Christian, can you please explain what these wordings were? And I said, okay, I will do this in this time before talking about it. So there are a few important terms. Cluster, which describe a ring of Cassandra nodes. Yeah, that's the ring you have typically if you look into Cassandra. A node is a Cassandra instance. As I told you, all these nodes are the same. There's something called replication factor. So how many copies of your data you want to store. So maybe one fact I've missed, it's distributed. So it's a distributed database. So you can store copies of your data. And you can choose a so-called replication strategy. So it's a simple one, or is it a network topology strategy? I will have some examples when we look into data center and zones awareness of Cassandra. And there's a partitioner. In this case, the default one now is the Murmur3 partitioner, and this one decides where to store on which node, for example, and these storings are based on tokens, and a token on a node is a hash value assigned to the nodes. So you can see this actually in the link planetcassandra.org. That's the open source community page, and I think all the stuff and the deep dive details are posted there as well. So locally distribution. This is one of the cases I like most because that's exactly what I have on my notebook. So your client, even if you want to use the Java client, the Python client, whatever, writes or reads to any node. So in my case, I have a Python script where I connect to one client, to one node, and my client driver is aware of all the nodes in the cluster because the CQL allows me to have rules on distribution and retries and stuff like that. So the node coordinates with each other, the so-called gossip protocols. For that you have something called seeds. So the first one in normally cases is the seed. If this one goes down, there's another one. So this is also no single point of failure. And data is read or replicated in parallel. So if the client writes into the ring, the data is written to 3 nodes in this case. And what's the reason for that? It's the so-called replication factor. So that's the first time this comes in touch. If you define how many copies of your data you want to store locally, you just have to add the replication factor to your key space. So key space is something like an instance or a description of the metadata. So in this thing, each node 60% of the cluster, 3 of 5 storing this data. Another case is something called rack and zone awareness. So this is the first thing is the normal config. This is just per default. You just deploy stuff and you create a cluster and this will happen because you configured nothing else. And if you want to have multiple racks in your data center, and to be honest, this is a bit focused on failure, because if you look in a data center, you have all those racks, and mostly, or most of the times, they are put in one USB, in one power cord, and yeah, they have those 16 ampere secure behind the rack. So if one goes down, most of the times it's the whole rack. So you can store your nodes in racks, in a zone, for example, and this allows you to store the data not on every second node, for example. It allows you to store it in racks. So if Cassandra is configured to be rack aware, you can store the copies in different racks. And that makes sense because if rack 1 goes down, for example, rack 2 and 3 have copies of the data and will be accessible as well. So in this case, it's replication factor 3. It's the most recommended, I think, because in every slide we have its replication factor 3. So in this case, this is stored 3 times. And it could be also that the coordinator node, which gets the request, stores data. So it's up to the partition it holds. And to have the whole world in Cassandra, it's also possible to have different data centers in different locations. And that makes sense because if your client writes local, the data should be, or maybe should, synced across the WAN. So in this case, the replication is done in one data center in Europe. For example, if your client accesses or writes there, and then it's synced to the other data center. And you can see it's also possible to have different nodes and different replication factors. So this refers to the network topology strategy. You need this because you have to inform Cassandra or the key space over the different data centers and how many replications you want to have in those. And there are some really good examples for that. So maybe if this goes down, so I fly back from San Francisco on Saturday, so it was 4:30, and I think a few hours later, there was this earthquake, and I think that's the best example why you need 2 data centers. Maybe one is in the ocean if you fly away. So this is one use case, and the other one is, for example, if your users are located in the US as well, and you have a client there, it makes sense that he can access the data on his data center, not in the one in Europe, because of the WAN lines. And remember the kept theory. I told you there are 2 facts. Yeah, it's availability and it's partition tolerance. Yeah, we have this replication factor, we have all that stuff, and sometimes it's a bit different. We have some customers and they ask, eventual consistency. This is a banking environment, and we need to know that the data is really written, and the default value for this consistency level is 1. So if anybody writes and you have a replication factor of 3, it's going to 3 nodes, and 1 has to accept or acknowledge this write. So in this case, data is written, and the consistency will be anywhere. Yeah? So it will be consistent, but not in the fastest time of the response. So the consistency is, in this case, only confirmed by the fastest acting node, and you can see, I think it's, is this micro? I have no idea. I think 5 microseconds, or hopefully 5 microseconds. So this one is in a case of 1 with a consistency level of 1. This is the one who submitted the write is acknowledged. If you have quorum, for example, which is another option, you can see that 51% have to answer. So in this case, a minimum of 2 nodes have to answer this request. Oh no, 3, sorry, 51, it's 2 plus 1 in the local data center. And you can see there's also an option called all. So if I go to a bank, I can say, okay, that's not a problem. We can wait for all those nodes, but in case, we are partition tolerant as well, but we have some trouble with the performance because you have to wait for all those nodes. So as you can see, there are some different kinds of consistency, and I think it's a big difference, and it allows you to tune your consistency. And you can even do this per query. That's really interesting. So sometimes you have applications that are not that interested in having the exact data at this time, but sometimes you make queries which are really hard in the consistency level, and you can just enable this for maybe one query. Yeah. So there's a blog entry as well. You can see it on the planetcassandra.org. I think I will refer that later as well. So this is really interesting, and keep this in mind if you think about consistency and everybody talks to you and says, oh, that's eventually consistent. No, it isn't. If you don't want to, it can become immediate consistent. So I told you.
What do you sacrifice then?
Sorry?
What do you sacrifice then? You can't be partition tolerant, so you must become unavailable.
Yeah, in fact.
If you want to be consistent at all times, you will become unavailable. Or will you not tolerate partitions and get a split brain? Can you get a split brain with Cassandra, or will you become unavailable?
I think it will not become unavailable until all. In this case, if it becomes unavailable. If the replication factor is 3 and only 2 nodes will answer, this request isn't successful, so it becomes an unavailable exception. You're right. Glad you pointed this out. So another thing we talked about this actually is the node failure itself. So if a node goes down and your write in this case is Chrome, it doesn't bring your whole data center down. It's the same if it is 1. Yeah, you just have to acknowledge from one host to get it back. In this case, it's replication factor 3. You see the response times, and in this case, replication factor plus consistency level allows you to be successful. If these cluster constructs and the nodes become more and more and increasing, so then it becomes quite better to have this replication factor. So the example of 4 or 5 nodes is always a bit limited in the view. So if a single node goes down, shouldn't be an error. If 2 nodes goes down, could be that there's as well no error. Yeah. If you have a node recovery, so there are 2 different states. It could be that the node is dead, it's really dead, and you have to order new hardware, which takes you 4 weeks, 2 days. Don't care about how long the data is, the hardware is ordered. In this case, I think you have to replace the whole node after 3 hours, because there's something called a hinted handoff. So the node storing a hint for the node which is down and for the data to replicate afterwards. So if the node comes back in this period, he gets the data replicated. But sometimes this doesn't, it is successful for the replication, but you have to run repairs, for example, because it could be that this node has data which was deleted in the meantime, or which has a tombstone, it's called. And he doesn't have that actually, so it's good to have a repair afterwards for this node if you're in this 3 hours timeline. Yeah, and the hinted write does not count to the consistency level. So this is not a count to the consistency. I told you that it could be that the whole rack goes down, and because of the replication factor and that the data was written into different racks, we can map the availability as well with the Chrome in this case, and with none as with 1 as well. So the data would be available in the different racks, and the client request could be answered. So the request will be a success. So we have rack, zone availability, we have the data center, and we have different continents if you want to. So I copied this because I looked into the paper. It was, I think, 60 pages. I can only understand half of that because it's a study. I have no idea what these guys were talking about. But I found that the screenshot is really showing what is going up. And I think the difference to the paper's DataStax offers is that this is a university. So if you look on the DataStax page and you will find some, whoa, we are scaling linear, then you will miss some facts, and it's always, yeah, who is the guy who pays this study? Yeah, oh, it was DataStax. Surprise. Yeah. So in this case, it's from the university, and you can see there's some well-known with us, and I think the left on the upper left shows the linear scalability of Cassandra. So adding nodes gives you more performance and more throughput. So that's just the fact of this one. Why is it so? I think I copied this slide from the training material. Hopefully no one will kill me for that, but I think this shows exactly what's happening. So it's write optimized. You're writing sequential. Everything is added at the end. So write it back always at the end. And it's fast merging. So you can see the coordinator. I think we talked about the MoMo3 partitioner and the coordinator, which is the node who gets the request. And this always writes into the mem table and into the commit log. So if we look onto node in the, I think it's share data or lib data, I have to check this. It's up to the derivative you are using, if it's just the tarball install or something. And if you write, it always goes to the mem table. What's the clue for that? Because data is accessible. So if you make a read on this partition key, you have the feature that this becomes really fast because it's in the memory. And after some times, those mem tables becomes full, and this is a so-called compaction. This calls a compaction, and in this case, it's also written sequential. This data gets compacted to the so-called SS tables, and these are stored in the file system. So we will see what the hardware requirements are in, I think, a few minutes, just on the last slide or something. I pushed this all together to show you how to start with that from the hardware perspective. So that's just that's because that's the reason why it is so fast, one of those. So it's just written fast. And in fact, sometimes I had to do with infrastructure in my past, in my personal past, and there was something I always had in mind, that RAM is always the limiting factor, not CPU. And Cassandra changed this. So sometimes writes are so fast that the CPU becomes the limiting factor. So we will see something like an 8-core CPU as a recommendation for a normal machine, for a normal node. So the operational simplicity, just in one slide, I think it's a few points, but it's a complete product. So there are not multitude components to install. It's not a framework. You don't have to write a lot of recipes or something like that to bring it up. It's easy to install, set up a monitor. Yeah, there's a tool called Op Center. We'll see this later, where you can just have a look on it. It's simple to administer and deploy. You can use Op Center, or you can use shell or scripts, whatever you want to. It supports snapshots and backups of your data, so you can time this if you want to. And it runs on commodity hardware. So my MacBook in this case is commodity hardware, and it runs on that. So no downtime is required. That's something I really like because of the masterless architecture, just adding and removing servers, how you want it to scale up, to scale out, whatever. Yeah. In case you see that your disk becomes full because of it's always writing data plus 50% for the compaction. So if you have 500 gigabytes of SSD, maybe you would change it to 1 terabyte or something. If this becomes full in your monitoring, then you just have to replace the node if you want to, in production. So regarding thrift and these old protocols, so forget about it. This is end of life, and I think if you call it anywhere, any tool using thrift, this will cause a line which writes you that this is end of life. So Cassandra query language based on a native protocol is the new standard, and the reason for that is to have it more simple and more usable for database admins, for programmers, for developers, however you call it, and to have statements which are similar to the well-known SQL statements. So CQL is intended to provide something easier and something you maybe already know. So like select all from users is a typical case. With using CQL in your driver, it's okay. Yeah, you can use all these normal commands, but there's something called CQL SH. So you have a shell for CQL, and this interface comes directly with your install. And you can see things like capture or consistency. You can set consistency levels in CQL, and you have something like describe. Wow, how does my table look like? I have no idea. I have to go to the opposite, and just get in. Describe table tweets, for example, and you get the whole description, including all these commands. And there's something like copy. I liked it really much because, yeah, I missed actually that this was CQL SH, because I tried this in my Python code just to copy from a CSV file and copy the data into it. This was perfect on the shell, but not in the driver because it's the shell. So this allows you to import data, structured, unstructured, directly from documents into your Cassandra table. And you can do things like tracing, see how your queries are committed to the nodes. That's quite an interesting thing, how your query is distributed to all those nodes. And you can see this in, it looks like a log file. You can see to which node he's connected and he's speaking to, and what the actual token is he delivers. So nice functions in the CQL SH as well. And that's a short view. How does it look like? And you can see in this case they created a key space called leak, and in this case they chose a network topology strategy. And you can see data center 1 with a replication factor of 3. So this is maybe the Europe one. And there's a data center 2 with a replication factor of 2. So this allows data centers to store your data in different data centers with this replication factor. So this is ensured by Cassandra. And then we use this one and we create a table called teams. And you can see the team name, the player name, and the jersey, which is an integer. And there's something called primary key, and that's the key for the identification. It's the team name. And there's something like called player name, and this is a clustered column key. So your columns are able to, you are able to have a select from where. So if you don't use clustering column keys, you would be only able to select the team name or select all from the team name, from the teams. So this allows you, maybe in the data modeling example, this becomes a bit clearer. And you can insert stuff like you would do it on SQL. The interesting thing for me was that this is not limited to standard data types, so you have things like list, map, and set. And sometimes I hit this personally, you have the problem that this does not match maybe all of your needs, because if you look into the user definition of your Twitter account, and there's an API and you have something, a class called tweet, and there's another one which is users. And users, I thought, okay, it's a good idea, just use a map or something or a list and store the values as string or something. But sometimes there's a boolean, and sometimes there's the integer, because users is a complete type definition of something. So in this case, you have to think about a new table or a blob or something to store your data. But in case this fits, list, map, and set are really, really good to have data stored in a structured manner. So the interesting part, Internet of Things, data models. It's really often that people ask me, what's the best data to store in Cassandra? And I said, you can store every data, so there's no perfect match. And then I talked to some of the data model guys, and for me it's sometimes really difficult to understand what they're talking about. And they told me that time series and sensor data and all that stuff is something which is really a good fit because of the structure of the columns and the timestamps and stuff. And yeah, I would just try to point this out. And yeah, the Internet of Things is always a bit stated out as the machine-to-machine connection, or people-to-machine. And you can see a few examples here, so sensors and clickstream data, just clickstream in the web, or your temperature at your home or something. Last week I met a guy, they built something like a spinning bike which sends the data to the class. So they're sitting, they spin in front of their MacBook, which is put into the bike, and this bike sends the whole data all the time to the class, and so everybody can see that you are the slowest one, and well, maybe the fattest, I have no idea, because there's a camera as well. Yeah, good use case, I think. I'm not sure if this is the Internet of Things, but it collects sensor data. So there are some good examples like Netflix and stuff. So we have, yeah, Netflix is an example. They store data just to allow people to stop movies. And if you imagine of a family, 5 or 4 persons using Netflix, and everybody has its own preferences and stops movies at different timings, and you have to store this data because when they logged in again, they want to start the movie at this point and not anywhere else, so, or from the beginning. So that's, I think, a use case as well. So I tried to copy something from our guru, I would call him. He's an evangelist, and he said that data modeling is a process, so it involves a few things, and one of them is the collection and analysis of data requirements in an information system. Okay, that's not this hard. Then the identification of participating entities and relationships. So imagine a user by song or something table, so you have to care about the connections to each other. And then the identification of the data access pattern. This is really something that we always state as know your queries. And, yeah, I always sit in front of my code and think, okay, I have no idea what the query is they want to see. I just want to store the data in the exact way. But this becomes important because in terms of performance and clustering columns and indexing of Solr searches, for example, if your data model isn't right, it could cause some facts that slows your system down, and it's the only reason for that is not the Cassandra database, it's your data model, because it has wide rows with 2,000 columns, for example, where you store the same data, and you can solve that with choosing a composite partition key, for example. So there are some really interesting concerns. And yeah, you have to ensure that's a particular way of organizing and structuring your data, design and specification of a database schema, and the schema optimization and data indexing techniques. Okay, nothing I do. So data modeling becomes a mixture of science and art. So in case you're interested in data modeling, I think there are many resources for that. A few are on the third slide. So there are some YouTube videos where this guy describes what data modeling is and exactly what the difference is between storing data in a table fashion, which is 2-dimensional, and a column family. So Cassandra is column families, and you can't see anything about it if you look into CQL. So this is where it becomes really interesting, and these guys doing this all day long. So it's really science and art.
One question about that are you aware of any research or authoritative work on column families, as it were? I mean, when you look at the relational world, you kind of learn what the right way to model things is, mostly.
Yeah.
At some point you arrive at the third normal form, and if you depart from that, you need to have good reasons. But I'm not aware of anything like that for Cassandra or, in fact, any other NoSQL thing. All the NoSQL stores started to kind of depart from the relational model for good reasons, but you kind of had a loss when you start dealing with these things, and you want to model something that is non-trivial. And I guess, you know, things that go beyond what you will be able to show today, definitely. Then you kind of had a loss. How do I do this join? How do I do an end-to-end relationship? Or is it even the right way to think about these things? Is there any source for that? Any work, any paper, any website for Cassandra specifically?
Got it. It's too complex to have this in one answer, to be honest. And even there would be, I'm not aware of any white papers. What I know is something like you described, joins, which are simply not possible because data is distributed. This is done by something called Apache Spark. So Cassandra, in terms of DataStax, are the only ones who integrate this because of the limitation and unions and all that stuff. But in fact, this is so new that this isn't described as well, and there's no recommendation papers and stuff. So I think actually there's nothing.
Okay, cool. I was hoping for more. Last time I checked was a couple of years back.
Okay, a couple of years.
So I thought maybe by now there will be something more or less a standard approach to NoSQL data modeling in Cassandra.
Yeah, to be honest, there is an approach, and this is described in those videos. So have a look at them, and feel free to ask directly. So I can surely make in contact directly to the guy who distribute those. And this is something I told you because I'm not aware of what he's talking about. So it's really hard for me to understand. So I would love to have your name and come back with some information to this guy and how to have the recommendation standards for Cassandra. I think there are some, and it's just a bunch of videos, but I'm not sure if there's any white paper or something. So why Cassandra for time series? And in this case, Cassandra is based on the big table storage model. This is something we saw by the definition. And one key row and lots of variable columns. So you can have something like white rows where you have millions of columns. I think we are able to store 2 million or something. But in fact, this will limit your performance because you have to search for the row key, for example, which is your indicator for your search, but then you have to go over all these columns, and this could slow things down. So this is a single layout on disk. So if we have something like an SS Table Explorer, we can see how data is written, and you will be surprised it looks exactly like your column family, and it's stored sequential. So this allows speed. In this example, we are storing weather data. So we have one weather station, and temperature measurement is every minute. And you can see the row keys in this case is the ID of the station, and there's a timestamp and the degrees to that timestamp. So this is the time series with the degrees in this time. I think it's Fahrenheit because at 72 degrees I would go in the in the sea or something. How to query data? So the weather station ID, I told you, was the 100, is the locality of a single node. So you have a weather station and the date range, and you can see when the weather station is 100 and the date is this. The column will be found based on the row key, which is the weather station ID. So we can also have ranges, in fact, and you will see it on the bottom. You can just select ranges with a query. Data partitioned by weather station ID and time. Okay, so far so good. And the timestamp goes into the clustered column. Yeah, we will see, or I will try to explain what this is. And the store of measurement is a non-clustered column. So when we look into these, into the CQL statement, we create a table. The weather station ID is just the text. Remember the 100 weather station ID. And we have the timestamp, which is actually a timestamp, and the temperature text. So the primary key definition would be weather station ID is the row key. Yeah, you know this is the 100, and you have an event time. So these clustering columns allow you to have, in fact, a query to your data like, select weather station ID where time is 1st to 31st of August. So this allows you those word queries based on the clustering columns. Another alternative for that, if you haven't designed your cluster, and this is a good example for that. This is a clustering column, and you have to define it before using this table, because afterwards you are not able to add clustering columns. You can do with an alter table or something that doesn't work. It's permitted, denied, sorry. And you can do indexes as well, but this faces up to cardinality. So if an email address is there, often you have to index the whole row. In this case, keep in mind that this allows you to sort your data. So it's simple to insert into temperature, weather station ID, all that stuff. This is hopefully directly done by your sensor with a short wrapper or something around it after it. And then you can simply query the event time based on the weather station ID. I can show you in my environment what it is if you have this not, and how to create an index as a workaround.
So what if you want to get all the sensor events or weather station events readings for all the weather stations, starting at that time and ending at that time? So
if your weather station ID, if you have different.
If you don't care about the weather station IDs, you just want all the temperature readings. If you go back to the other slide.
This one.
So the
you can select star from.
Right. So if we just have the second query, the select query, and leave out the weather station ID part.
Yeah.
So in my experience, Cassandra then always warns you about something called filtering. So maybe you could elaborate on that.
Yeah, to be honest, there's something called allow filtering, but this is an option we suppose not to use in a production environment. So this is also something which causes a lot of indexing. To be honest, it's not the best thing I know about, so maybe we can talk this offline later on. So it's just because of the limitation of my knowledge, but I know this option, and we have to check this afterwards. So I come back to you, and I have some interesting slides. I can show you to that. It's okay. Thank you. So with the previous table, you can end up with a very large row on one partition. So keep in mind, we saw this. You have all those timestamps with the degrees, so this becomes large in the fact of scale out. It goes in the white. And yeah, primary key, weather station ID, event time. This have to fit on one node because it's a row, and the rows are stored on one node. Yeah, it's stored and replicated to others if you want to. And there's the count. Cassandra can store 2 billion columns per storage row. So in fact, this is possible, but yeah, it's not the best example to have this in your search query because you have to query over all columns. So in this case, the description is to have a composite partition key to split those things up. And you can see that the weather station ID and the date is now the primary key. So you summarize those in your column. So it's the column key, and the value is the event time. So with this, you're able to change the whole data into a model which it's just easier to have this in mind. So if you look into, so it's a bit strange to in normal cases I would send this to the white belt. So in this case, there's your weather station ID, and this is now coupled with the date. So, yeah, so you have something weather station ID double point timestamp. So you query for the weather station where time is, and you get the value back. So this becomes partitions, not rows, not columns. Sorry. Maybe we can check that later on the whiteboard. So the primary key, that's well known. The key uniquely identifies a row. In the first case, this was the weather station ID. In the second one, it was weather station ID plus timestamp. And a compound primary key consists of a partition key and those clustering columns. You have seen this. The partition key was the first one, and then those clustering columns I described as you can change it. You can't change it afterwards. And the partition key determines on which node the partition is stored or resides. Because if you make a query, your Cassandra cluster has to be aware of on which row he has to search, which node holds the data. And this is because of the token hashing we had in the beginning. This is where it determines where the data is stored. And the data is ordered in a clustering column within the partition. So this was the second one. Yeah. If you have questions, I'm not the perfectly right person for that. There are some different parts to become a super data modeler. I'm not sure if you have those 3 hours for one video, maybe. You can check that online. And it's for the easiest way of storing data. That's maybe not the interesting part, but as you maybe turn out, if you go into production and you have complex queries and you store massive data, then you have to care about this and you have to think about your data model before using Cassandra. or before creating tables, because sometimes, yeah, you can change a lot, you can add columns on the fly, that's not a problem, but keep in mind that 2 billion columns could be a mess. So now the 3 minutes, who's DataStax? DataStax, I showed it before, we are the company behind Apache Cassandra. We not own Apache Cassandra, we just commit 80% of the code. We actually have 350 plus persons now, and we were founded in April 2010. We have in different locations some offices, and there's one in Paris as well. There's none in Germany actually, but our one is in UK and London. We have over 500 customers, 25% of the Fortune 100, and you can see some really good examples with eBay, with Spotify and Netflix, for example, and there are more to come which are using Cassandra for different use cases. And I think on the Planet Cassandra page there are some really interesting use cases. Sometimes I'm wondering what we are doing with the Cassandra database. DataStax itself delivers some values. So it was founded around the database because of, as they used Apache Cassandra, there was no one to support that at Rackspace or Facebook. And so Jonathan Ellis and Matt Fry decided to support this database with support and training. And yeah, I stated it out that the training was that perfect. I've never had those trainings before, and I was really surprised how experienced those guys are. They develop EDEs and drivers, so we will see some of those, and these Java drivers and Python drivers are developed by DataStax guys, and we also offer professional services. And if you think about not only about the database, if you think about enterprise functionalities like Solar Search, like Apache Spark, or in-memory features or management services, this is something we add as value to the DataStax Enterprise, which is the enterprise version of an Apache Cassandra database. So it's not the actual newest release, because sometimes in an enterprise environment this could be not the best option to use the newest one, so we sell this as the supported one. And you can see some of the interesting things, and on the right side there's something like a split cluster. You can see Cassandra nodes and you can see Hadoop nodes, and this is also the thing with Spark, so the resilient data sets are located on the Spark nodes, and you can access the Cassandra nodes directly, so you can have mixed load data centers. Yeah. There's something called DataStax Ops Center, or in general Ops Center, because this is available with the community version 2, so you can just download it and use it. It's free, and there are some minimal functions you have to ensure in an enterprise environment. This allows you to have a browser-based visual management, and you can add some monitoring. This is really interesting to see how your latency is, how the write throughputs are and stuff. So for monitoring, this is really interesting, or you can just use the API to determine this. And we also push some native drivers into the community. You can see the download location, and this allows you something like having a Java driver which is aware of the whole cluster, and he gets the reports how many nodes are available, and you can try to reconnect or retry policies in general for your queries. And there's something called Dev Center. This is something like the SQL Management Studio. You can just query things there, and you can see your connections and your tables. I just want to stress that much. We have an office demo. If you ever have the chance to come to Santa Clara, just press the red button. So you will bring down a whole data center of Raspberry Pis. Okay, it's not the typical server environment, but it shows the availability of Apache Cassandra, and that it runs on commodity hardware. Yeah. I'm not sure. Maybe I will buy some and build this on my own to bring this with me. So that's a really interesting case. There's a big red button, and if you press it, they shut down the whole data center. Yeah, there's some comparison. I'll skip that. If you're interested, feel free to come to me. And yeah, Netflix is a use case. They preference data. I told it to you. They store this data. Where was the movie stored? Who's the guy who wants to see that? Comcast, they are a big provider, broadcast provider in the States, and they have something like an X1 box where you can now command stuff between a football game, for example. So they have interaction within their boxes, and this is stored or powered by Cassandra. And the weather channel, this is really interesting because they're doing all the data, stat tracking, caching data mashups, and even their content generation system where they give data to others is powered by Cassandra. So something to the what's new. A Hadoop node with MapReduce. I'm not sure if you ever tried this. It took me a lot of time to make a word count on Cassandra data because you have to think about it. You have to write routines, and even I just wanted to do this with Hive, and that was not the easiest part, and especially it wasn't fast. And if you look to Spark, this should be 10 to 100 times faster than Hadoop MapReduce, so it is near real time. It allows streaming in the next version, so when it is integrated into Cassandra. And there's an example as well for the mixed load Cassandra cluster. You can see that there's a cluster only holding the Cassandra nodes, and there's another one with only 4 nodes for the analytical data. So you can split your queries if there's a company which only wants to analyze data. You can give them access to a cluster, and this one is replicating, gets the replicated data from the Cassandra cluster. Yeah, it has in-memory storage for reading data. So if you use the shell and you write data, it's stored in memory, and you can access this really fast. So I think there are only four companies actually using or having a commitment with Databricks. This is the company behind Spark, and we are one of them, and we are the only one with a database, so the other ones are Hadoop distributions. And there's the answer, why should you do this? Because you can't do joins, you can't do unions on the CQL SH because of the limitation. And with these resilient data sets, which is the data model in Spark, you can use this. So this is our workaround to have this fast and accessible. And it allows you a lot of features I've never seen, actually, because it's that new. And you can aggregate data or stream processing in the next version with Spark. And it also promotes some HA capabilities. So you can see on the node cluster that there's a Spark master and there's also a standby master. So we always try to enhance the HA capabilities. So for example, if you have a node which should be a solo node, you have to ensure that all the nodes in the cluster become or in the data center become a solo node, and this allows you the same capabilities you have with Cassandra. So this is really interesting because it always adds a bit of availability to those enterprise tools. And I talked about list, set, and map, I think, and I limited it by myself with the users example. And there's a new user-defined type in the 2.1 version of Cassandra. And I really like this because it's exactly the case I was looking for. I want to describe my type by myself. So I want to describe that the name is a text, that the birth date is an integer and all that stuff, and it's not a list of string and string. So this is to come with the 2.1 release. And you can do secondary indexes on collections as well. So if you have a set, a list, or a map, you can now set secondary indexes on that to just have a look on them. I think it's the last slide, how to start. And yeah, I told you, Cassandra is so efficient in writing that CPU can become a limiting factor. So minimum of 8 GB of RAM because of the JVM. There are a lot of recommendations for that. There are good web pages explaining how the JVM is perfectly tuned for Cassandra. And yeah, an 8-core CPU is SSD. I told you that you have to be aware of 50% capacity overhead for your compaction. Remember the mem table, commit log, and the SS table compaction, which is written to disk. And the minimum recommendation is 3 nodes. As an alternative, just use the Amazon images. So, thank you. I don't think we have any time left.
Yeah, no time left.
Okay, sorry about that.
If you have questions, any questions?
Why can you not start with just 2 nodes? Why is the minimum 3?
So this is just because of the replication factor. You can just start with 1. if you want to. You can just bring one node up, and you have never the chance to change your consistency level to 3, your replication factor to 3. But you can just use an Ubuntu, install it, and before these virtual nodes with the partitions and this distribution around the ring, there was something like static nodes, or I'm not sure how this was called, and there you can just numberize your nodes with 1, 2, 3. Even if you want to put more into the cluster, so you can just start with one, but I don't think it makes sense.
What would happen if I have only 2 nodes and a replication factor of 2, and one node goes down?
In this case, your query is gets a feedback that there's an that this was not successful. So, because the
you no longer write then?
Oh no, sorry, I'm wrong. Your replication factor is 2. If you write data, the data will be written, but node 1 stores the hints for node 2. And if you now try to query data and you have a consistency level of 1, so only one node must respond or acknowledge, then it works. So your response will be answered. Your request is a success. If you use quorum, any will work as well because of 1. It's just one of the nodes. And yeah, just keep in mind that you can't use quorum or all. So if all is the consistency level, because you have to ensure this, it will fail. But the replication factor just ensures that the data is replicated. In case the one node is down, it becomes after 3 hours because of the handoff. And you are also able to define a replication factor of 3, even if you have 2 nodes. But in this case, every request will fail. So thank you.
More questions?
So you mentioned that there's Solr integration. I was wondering about Elasticsearch. Do you have that, or?
Yeah, hopefully Elasticsearch uses Lucene as well as the underlying engine. So in this case, we both using Lucene, and in fact, anybody has decided to use Solr. I can find some lists where we describe why we use Solr. But in fact, I use it a lot now. To have those faceted search and text search, and it becomes really fast. And my lovely example is you go to a web shop, you want to see how many Nike shoes are left, and you have this table on the left side with 3 Nike, 2 Adidas. That's exactly an example for Solr. And I think it's, I'm not aware of the typical differences. I've heard that Elasticsearch is a bit faster, but I'm not sure if this is the only fact.
I think it's more a case of products that do the same thing, but in a very different way.
Okay.
So I'm a big Elasticsearch fan, and basically.
Okay. Yeah. Sorry about that.
Ex-Solr user.
Ex-Solr user. Yeah. Okay. Maybe you should write this into the media group, and I can post it to the product guys.
But more general, is it possible to sort of listen for changes in a Cassandra cluster and subscribe to that and act on that?
That's something I don't get right.
So basically, if you look at CouchDB, for example, it has a change feed, which you can use to implement replication to something else. I was wondering if something like that exists on the Cassandra side.
I think there's something called a listener, or something where you can listen to queries, and if there's something happen, you can do something.
Right.
There's also something like timeouts. You can set TTLs and counters and stuff, but this will be then I have to talk 2 hours maybe. So there are some features like that, and I would love to look over them with you. So
great, thank you.
I was curious about what you said about integrating Cassandra and Spark.
Yeah.
And on your slide, you wrote that. Maybe you could go back to the slide real quick.
Just a second.
You wrote that every node is also a Spark worker. So are you suggesting that every Cassandra node also doubles as a Spark worker? And how would that work with memory requirements? Because both Cassandra and Spark are very memory-hungry things.
Yeah, you have to. It's the easiest way. You have to put in memory into the machine. To be honest, it's the same with the Solr stuff. If you decide that your node becomes a Solr node, you also have to know about the faceted search, and you have to have those 50% overhead of disk capacity for the Solr as well, because this mechanism needs to have a separate disk. So it could be that you have a Hadoop node with the Spark stuff on it, and you have to, in this case, there was an example where you have 4 nodes of Cassandra plus Spark, and you are able to get the data from them, but you have to ensure that the measurements for RAM and drive and stuff is increased as well. So.
But what's the advantage of having both running on the same instance or both in the same machine?
In this case, it's because of the data access. So Spark is can distribute. So I'm not sure if I skipped the slide, so maybe it's my fault. I had a slide where I can just where I just described how to Spark on Cassandra, and Cassandra tables are. I'm searching for the right word. You can access Spark RDDs as Cassandra tables. So that's the real benefit. And if the data is replicated to this data center, we're using Spark with your 3 nodes, 4 nodes, whatever, to keep it in availability. You can access the data directly from Spark in the Cassandra tables. I think that's a big difference if you're using HDFS, for example, in MapReduce, where you have to put all the data in a file or something. So here you're able to access the data directly. So it's my fault because there was a slide describing exactly that. Sorry about that.
You can do that also if you could do the same thing if the Spark worker is running on a different machine than the Cassandra node, right? There's nothing special about both of these things running on the same machine, except maybe that you reduce the network latency.
No. It's maybe you have maybe it's good because actually this node has this row, then it becomes a bit faster. But you can also have Cassandra nodes accessing Spark nodes accessing Cassandra nodes. So that's also possible. There's a config file. It's called Cassandra. I'm not sure if it is the environment. It's the DSE default in the DSE, and they can just by 0 or 1 decide what your node role is, and you can just activate it. And you can see it in my example. I have 4 nodes, and one I had activated as a Spark worker, and this one has the shell. So when I go now with SSH on this node, I can access the data of the Cassandra database as well. So that's not a problem. You can use. So maybe you can look at the shell and you can try it out. Would be nice. Okay.
I have a question. What is the minimum amount of data I need, or it makes sense to use Cassandra? Because if I have 1 megabyte or 2 megabyte, it doesn't make sense to use Cassandra, right? So what is the minimum amount it makes sense to use something like Cassandra?
I don't think that the amount of data you're storing is the exact factor for describing what Cassandra can do for you. So I think all the features we looked into, it's just on, you can store 1 megabyte, so my tweets, I think I have 7,000 rows or something like that, and it's 30 megabytes. But I have exactly, if we can go through the use case later on, you can see what has happened when one node goes down. Your data is written as well. You can read data and so on. So I think I've never heard of any. It makes sense to use it for minimum 100 megabytes. In fact, the complete community edition is free. So everything you've seen or you will see in those demo environment is free. And in looking into the future and to scalability, I would think that starting with Cassandra absolutely makes sense because I've seen companies changing from Postgres to Firebird and back and forth, and it always hits you directly in the face because you shoot you in your feet or something because you always have to deal with those. So if you decide to use it, even if there's not that much amount of data, feel free. Keep in mind it's designed for writes. So if you store data fast and you have different channels to store data, it's the perfect match, and even if the data is only 1 byte. Yeah.
Okay, thank you. I have many more questions, and I guess many people here as well. But we make now a short break, and then we will continue with React talk, and then the pizza is coming. So if you have questions, just go directly to Christian and talk with him.
Okay.
And grab beer and Club Mate in the fridge. Just help yourself.
Yeah, thank you.